In this part, we will discuss positive interactions. Positive interactions. Positive interactions. Positive interactions are those interactions in which either both of the interacting species are benefited or at least one of the interacting species is benefited. The other species may or may not be benefited, but is seldom harmed. These are positive interactions. If I will repeat what positive interactions are, suppose there are two species, A and B. These interact with each other, and their interaction is positive. There are two possibilities. Either both of them will be benefited, or at least one of them will be benefited. It means neither of the two in these interactions, positive interaction, is harmed. Either both of them are benefited or at least one of them is benefited. These are positive interactions. Positive interactions are of many types. Let me tell you. Number one type, mutualism. This is one type of positive interaction. Number two, proto-cooperation. Number three, commensalism. These are some common types of positive interaction. To understand these various types of positive interactions, we use signs such as plus sign, minus sign, zero sign. We use plus sign to indicate that the species is benefited in this interaction. We use minus sign which indicates that the species is harmed. And we use zero sign to indicate interactions that these interactions are neutral, neither beneficial nor detrimental. These are some signs. And we can do one thing. We can make a tabular representation of different types of these interactions, which will have this tabular representation will have three columns. Suppose column number one, species A. column number 2, species B, and then type of interaction. These are 3 columns. Suppose in an interaction, a species is benefited. If it is benefited, we write plus. And in the same interaction, if B species benefited, we write again, plus. This type of interaction in which both of these species are benefited, this is known as mutualism. Mutualism. The type of interaction here is mutualism. Let us discuss this mutualism. Let us discuss these one by one. One we have written here is mutualism. Mutualism. Positive interaction mutualism. Let us go for mutualism. Mutualism. Okay. Mutualism. Mutualism is that type of positive interaction in which both species are benefited. Both species are benefited. Both the interacting species are benefited in this type of interaction. Examples of mutualism are, number 1, lichens. Lichens provide the best example of mutualism. What are lichens? Lichens are the intimate symbiotic relationship between fungi and algae. Lichens are the intimate symbiotic relationship. Lichens are basically the intimate symbiotic relationship between fungi and algae. Between fungi and algae. These fungi and algae in these lichens give benefit to each other. The fungal part of the lichens absorbs water and minerals from soil and supplies water and minerals to the algal part, whereas the algal part, which belongs mostly to the green algae or blue-green algae, prepares food by the process of photosynthesis and supplies food, provides food to fungus also. First, it utilizes its food for its growth and then also supplies some of this food to the fungal part also. Because fungi are saprophytic. They can't manufacture their own food. Hence, they are dependent on algal part for their food. And this type of association in which both of them are benefited, and this is a permanent type of association. None of the two parts, either fungal part or algal part, can live independently under natural conditions. Such associations are called as symbiotic associations, and this phenomenon is known as symbiosis. Symbiosis. This is one example of this mutualism. Now come to the next example, that is number 2, mycorrhizae. Mycorrhizae. Mycorrhizae are the associations between the soil fungus and the roots of higher plants. Soil fungus and the roots of higher plants. These are mycorrhizae. Fungus absorbs minerals, essential minerals, especially phosphorus, and supplies these essential minerals to the higher plants such as pinus, while in return gets food from the plant. This is again a symbiotic association, because it has been observed that in a soil, if from these plants fungus are removed from the roots of these higher plants, if fungus are removed, these plants show stunted growth. These plants show poor growth. Hence, these are the 2 examples where the association between the organisms is beneficial to both, and it is very permanent. The associating organisms in these 2 examples, where lichens are, such as lichens or mycorrhizae, they cannot live independently under natural conditions when separated. Alga and fungus in lichens cannot live separately under natural conditions independently. Roots of higher plants and the soil fungus, they also are independent to each other. They also depend on each other, because it has been observed in various cases that when the fungus was removed from the roots of higher plants, the growth of higher plants was decreased. The higher plants showed, stunted growth, poor growth. These are 2 examples which are regarded as symbiotic mutualism, symbiosis. Now let's come to the 3rd example, where the association between the 2 interacting species is not permanent, it's a temporary one. While we saw in lichens and mycorrhizae, the associations between the individuals or organisms was of the permanent nature. But I am telling you, the 3rd example, where the association between 2 organisms is not permanent, it's of temporary nature. Let me talk of an example. Plants and pollinators. Plants and pollinators. This is an example of mutualism. Plants and pollinators. Plants produce flowers. These flowers are to be pollinated. These flowers are to be pollinated to continue the race of these plants. And pollinators are the animals, right? Most of the pollinators are insects. So plants depend upon insects for their pollination and for dispersal of their seeds. Right? Now, animals help them in pollination and dispersal of seeds. But animals are to be rewarded for this. Plants have to pay rewards or fees to the animals. And plants do pay these fees or reward in the form of pollen grains and nectar to the pollinators. And juicy and proteinaceous fruits to the seed dispersers. So, I hope that you might have got what I am telling. I am telling you that plants need pollination. Plants need their flowers to be pollinated. Plants need their seeds to be dispersed. For this, they take the help of animals. But animals don't do this duty free of cost. They want fees for this service to be paid. They want some reward for this service to be paid. And plants do pay this reward or fees in the form of pollen grains, which are taken by insects or animals as their food, and nectar to the pollinator, while as seed dispersers take juicy and proteinaceous fruits. But this is not always true. While some plants pay rewards to the service of animals or insects, some plants don't pay rewards. They get their flowers pollinated without paying any reward. This is known as sexual deceit. I will quote you an example. There is a mutualistic association between orchids and bees. Orchids and bees. Like other plants, orchids do not pay fee or reward to bees for pollinating their seeds or flowers. Seeds or flowers. How it is done? Orchids are flowering plants, they have flowers of different sizes, colors. There's a diversity of flowers in orchids, right? One orchid, Ophrys, that orchid is known as Ophrys, which lives in Mediterranean region. Its flowers have petals, and one of the petals of this flower of this plant resembles female bee in color, size and markings. When male bee visits to this plant, he mistakes this petal of flower as female bee, and he pseudo-copulates with this petal which is considered as female bee by the male bee. During the course of action, this male bee is dusted with pollen grains from this plant, from the flower. When the same male bee visits another flower for another act of copulation, pollination takes place. And this is sexual deceit. How? Because office plant got pollinated, but this office plant didn't pay any reward or fee to the male bee. Okay? This is sexual deception. This is sexual, deceit. Where sometimes some plants get their flowers pollinated and get their seeds dispersed without paying any reward or without paying any fee. The example is of mutualism, association between office and bees. Now I will tell you another example. That example is between fig and fig wasp. Fig and fig wasp. This is another example of mutualism. Fig trees are usually pollinated by special types of wasps. Those wasps are known as blastophaga. How these wasps, pollinate the fig trees. Fig tree has a hypanthodium type of inflorescence, which is spherical and has a hole at the top, which is known as ostiole. In this inflorescence of fig tree, there are 3 types of flowers in hypanthodium. The male flowers are near the hole or this opening. Then female flowers are of 2 types. In the center there are female flowers which are sterile female flowers, and they are also called as gall flowers. And in the bottom of this spherical structure hypanthodium, there are female flowers which are fertile flowers. Now, female wasp enters into the hypanthodium and lays eggs in the middle part of this inflorescence. That is in sterile female flowers. Okay? And then escapes from the hypanthodium. During entry and exit, this wasp is dusted by the pollen grains. When same wasp, visits another flower, pollination takes place. Here, both of them got benefited by the association. How? Fig got its flower pollinated, while as fig wasp used the inflorescence of this flower for 2 purposes. One, for laying eggs. Other, the young ones or larvae of fig wasp got food material in the form of female flowers. They used sterile female flowers as their food, and both of them got benefited. Here in this association, we may say that fig and fig wasp are largely dependent upon each other because fig can only be pollinated by a special type of wasp, while as wasp, these special types of wasps lay eggs only in fig inflorescence. Thank you. We will discuss another.